March 15, 1943. Henschel and Son Tank Works, Kassel, Germany. Production Floor 7. Chief Engineer Wilhelm Hoffmann set down his morning coffee and stared at the production report that would haunt German tank warfare for the remainder of World War II. The numbers were precise, devastating, and would never be discussed in any official Wehrmacht briefing. Monthly Panzer IV production, 267 units. Estimated Soviet T-34 production, 1,200 units per month. What none of the assembled engineers knew was that this single production analysis would reveal the mathematical impossibility of German victory on the Eastern Front, proving that the war would be won not by superior engineering or tactical brilliance, but by the brutal arithmetic of industrial capacity. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. The report lying on Hoffmann's desk contained intelligence gathered from captured Soviet documents, aerial reconnaissance of enemy factories, and statistical analysis that challenged every assumption about German technological superiority. While German engineers had focused on creating the world's most sophisticated tanks, Soviet factories had perfected the mass production of adequate weapons. The mathematical equation was becoming clear. Germany was building 6,000 masterpieces, while the Soviet Union was manufacturing 84,070 functional war machines. In the humid atmosphere of the production facility, surrounded by partially assembled Panzer IV chassis and the sound of precision machinery, Germany's finest tank engineers would confront a reality that contradicted everything they believed about quality versus quantity. The war they thought they were winning through superior technology was actually being lost in the factories of the Urals, where Soviet workers were producing tanks at rates that German industry could never hope to match. By March 1943, the German war economy had achieved unprecedented levels of efficiency and production quality, but remained constrained by fundamental limitations that would prove decisive in the prolonged conflict on the Eastern Front. German tank production had been organized around principles of precision engineering, advanced metallurgy, and complex mechanical systems that maximized individual unit effectiveness while minimizing production speed. The Panzer program represented the culmination of German engineering excellence applied to armored warfare. Each tank incorporated sophisticated transmission systems, advanced optics, superior armor metallurgy, and precision-manufactured components that gave German crews significant advantages in individual combat engagements. The Tiger I tank, entering production in 1942, mounted the formidable 88mm gun and featured armor protection that could withstand most Allied anti-tank weapons. But precision engineering required skilled labor, specialized materials, and extended manufacturing time that limited production capacity even under optimal conditions. A single Panzer IV required 55,000 man-hours to complete, utilized strategic materials including chromium and molybdenum that were increasingly scarce, and demanded quality control standards that prevented rapid expansion of production facilities. German industrial planners had calculated tank requirements based on assumptions about campaign duration and enemy capabilities that proved catastrophically incorrect. The initial German strategy assumed that superior individual tank performance would compensate for numerical disadvantages, allowing smaller numbers of advanced vehicles to achieve decisive victory against larger numbers of inferior enemy tanks. These assumptions had proven correct during the early phases of Operation Barbarossa, when German panzer divisions achieved stunning victories against Soviet forces equipped with obsolete tanks and inadequate training. The mathematical equation had favored Germany. 100 superior tanks could defeat 300 inferior tanks through better armor protection, more accurate guns, superior crew training, and advanced tactical coordination. But the mathematical equation began changing as Soviet industry relocated beyond German bomber range and began producing tanks in quantities that overwhelmed German production capacity regardless of individual unit quality. Intelligence reports from the Eastern Front indicated that Soviet tank production was not just exceeding German output, it was accelerating at rates that suggested unlimited industrial capacity. The German approach to tank development reflected broader cultural and industrial values that emphasized craftsmanship, technological innovation, and individual unit superiority over mass production efficiency. German engineers approached each tank design as an opportunity to incorporate the latest advances in metallurgy, optics, communications equipment, and mechanical systems. Preparing and narrating this story took us a lot of time, so if you are enjoying it, like this video. It means a lot to us. Now, back to the story. Ferdinand Porsche, the brilliant automotive engineer assigned to develop advanced tank designs, epitomized the German philosophy of technological perfectionism. His Tiger.P design incorporated revolutionary electric transmission systems, advanced armor arrangements, and advanced fire control systems that represented the cutting edge of military technology. Each Tiger.P was essentially a custom-built precision instrument designed to achieve maximum battlefield effectiveness regardless of production complexity. Heinrich Clausing, chief production engineer at the Krupp Steel Works, had developed manufacturing processes that produced armor plate superior to anything achieved by Allied industry. Krupp armor incorporated nickel-chrome alloys, advanced heat treatment processes, and quality control standards that ensured consistent protection characteristics. But these advanced metallurgical processes required specialized furnaces, skilled technicians, and strategic materials that limited production capacity to dozens of tanks per month, rather than hundreds. Dr. Richard Spielberger, directing tank development at the Army Ordnance Office, approached each design project with scientific rigor that prioritized performance optimization over production efficiency. Each component was tested extensively, modified repeatedly, and perfected to achieve maximum reliability and effectiveness. This engineering philosophy produced tanks that were individually superior to most Allied vehicles, but created production bottlenecks that prevented Germany from achieving the numerical superiority necessary for sustained operations across the vast Eastern Front. German factories were producing mechanical masterpieces, while Soviet factories were manufacturing functional war machines in quantities that would ultimately determine the outcome of armored warfare.
Mikhail Koshkin's T-34 design philosophy represented a revolutionary approach to tank development that emphasized practical effectiveness over technological sophistication. The T-34 incorporated sloped armor for maximum protection per ton of steel, a reliable diesel engine that reduced fire hazards, and mechanical systems simple enough for rapid production and field maintenance by minimally trained personnel. The T-34 design eliminated non-essential complexity that complicated German tank production. Internal components were designed for manufacturing simplicity rather than optimal performance. Armor plate utilized basic steel alloys that could be produced in any heavy industrial facility. The transmission system used proven automotive components that could be manufactured by tractor factories with minimal modification. Most significantly, the T-34 was designed from the beginning for mass production using semi-skilled labor and standard industrial equipment. Soviet planners had calculated that producing 1,000 adequate tanks was more valuable than producing 100 superior tanks, especially when those adequate tanks could be manufactured continuously while superior tanks required lengthy production processes that created vulnerability to strategic bombing. Soviet factory organization reflected this mass production philosophy through standardized assembly line processes that maximized output while minimizing skilled labor requirements. Workers were trained to perform specific assembly tasks repeatedly rather than understand complete tank construction. This specialization allowed rapid expansion of production capacity by training new workers quickly and efficiently. The Tankrograd complex in Chelyabinsk represented the ultimate expression of Soviet mass production philosophy. The facility combined tractor manufacturing equipment, steel production capacity, and automotive assembly lines to create an integrated tank production system capable of manufacturing 18,000 T-34 tanks annually. The entire facility operated continuously, with 3 shifts maintaining production 24 hours daily, regardless of weather conditions or strategic bombing threats. By early 1943, the statistical disparity between German and Soviet tank production had become so significant that mathematical analysis revealed the ultimate futility of continued German offensive operations on the Eastern Front. Intelligence reports compiled by Wehrmacht economic analysts painted a picture of industrial competition that Germany could not win regardless of tactical success or individual unit superiority. German tank production had peaked at approximately 500 units monthly across all types, including Panzer III, Panzer IV, and the new Tiger I tanks. This production rate represented maximum industrial capacity, utilizing available steel, strategic materials, skilled labor, and manufacturing facilities. Expanding production beyond 500 units monthly would require resources that were needed for aircraft production, naval construction, and ammunition manufacturing. Soviet tank production, based on documents and aerial reconnaissance analysis, was estimated at 2,000 to 2,500 units monthly and continuing to increase. The Tankrograd facility alone was producing more tanks monthly than all German factories combined. Additional Soviet production facilities in the Urals, relocated beyond German bomber range, were achieving similar output levels using industrial equipment evacuated from Western territories during 1941. The mathematical implications were staggering. Soviet tank production exceeded German output by ratios of 4-to-1 or 5-to-1 and was accelerating while German production remained constrained by material shortages and bombing of industrial facilities. Even assuming that German tanks achieved kill ratios of 3-to-1 or 4-to-1 against Soviet vehicles, the numerical disparity guaranteed that German tank forces would be overwhelmed through simple attrition. Strategic materials analysis revealed additional constraints that limited German production expansion possibilities. Chromium requirements for advanced armor steel exceeded available imports from neutral countries. Molybdenum stocks were depleted to critical levels. Skilled machinist availability was limited by conscription requirements for infantry and Luftwaffe personnel. Soviet industrial capacity appeared unlimited by comparison. Steel production in the Urals exceeded pre-war German output. Raw materials were available from territories beyond German military reach. Labor forces included millions of workers relocated from Western regions, plus prisoners, volunteers, and impressed personnel who could be trained for specific manufacturing tasks. German military intelligence had initially underestimated Soviet industrial capabilities, but by 1943, accurate assessment of enemy production capacity was becoming impossible to ignore. Reports from multiple sources confirmed that Soviet tank production was not just exceeding German estimates, it was approaching levels that challenged basic assumptions about industrial warfare. Colonel Reinhard Gehlen, directing Wehrmacht intelligence analysis for the Eastern Front, had compiled statistical evidence that contradicted official optimism about German prospects for ultimate victory. Soviet tank losses during 1942 had totaled approximately 15,000 vehicles through combat damage, mechanical failure, and strategic withdrawal from untenable positions. German production during the same period had delivered over 25,000 new tanks to operational units. The enemy was not just replacing losses, they were expanding armored strength by 3,200 vehicles quarterly, while German forces were contracting through irreplaceable equipment losses. The mathematical trend lines indicated that continued operations would result in complete German armored force depletion within 18 to 24 months. Colonel General Heinz Guderian, the father of German armored warfare doctrine, was present during this statistical analysis and understood immediately that traditional concepts about tank warfare superiority were being invalidated by industrial mathematics. Individual German tanks might achieve superior performance in direct combat, but superior performance was meaningless when outnumbered by ratios exceeding 10 to 1.
The strategic implications extended beyond immediate tactical considerations. German offensive operations required numerical superiority, or at least parity, to achieve breakthrough success. Defensive operations required sufficient reserve strength to contain enemy penetrations and conduct counterattacks. Both offensive and defensive concepts assumed the German forces would maintain adequate equipment levels to execute planned operations. But the production statistics revealed that German armored strength was declining while Soviet strength was increasing exponentially. Every successful German tactical operation depleted irreplaceable equipment, while Soviet forces could absorb tactical defeats and return to offensive operations with greater numerical strength than before. Field Marshal Erich von Manstein, commanding Army Group South, submitted strategic assessments that confirmed the operational implications of production disparities. German armored divisions were being reduced to regimental strength through attrition that could not be replaced with existing production capacity. Soviet armored formations were being reinforced to strength levels exceeding their original authorization through continuous equipment deliveries from industrial facilities. The realization forced German military planners to confront a fundamental contradiction in strategic planning. Germany had initiated war against the Soviet Union, assuming that superior military effectiveness would compensate for numerical disadvantages. But numerical disadvantages were increasing rather than decreasing, while enemy military effectiveness was improving through experience and equipment modernization. German engineers had approached tank design with scientific precision that optimized individual vehicle performance while inadvertently creating production constraints that limited total force effectiveness. Every technical advantage incorporated into German tank designs required manufacturing complexity that reduced production speed and increased unit cost. The Panzer IV, Germany's most successful tank design, incorporated a torsion bar suspension system that provided superior cross-country mobility but required precision manufacturing and specialized steel alloys. The transmission system utilized synchromesh gearing that improved operational reliability but demanded skilled assembly by experienced technicians. The turret design incorporated advanced optical range-finding equipment that enhanced gunnery accuracy but required precision machining and electronic components manufactured by specialized facilities. These technical sophistications provided measurable advantages in individual combat engagements. German tank crews achieved higher hit probabilities, better armor protection, superior mechanical reliability, and longer operational range than most Soviet tank crews. But technical superiority was being overwhelmed by numerical disadvantages that were increasing monthly as Soviet production exceeded German output by ever-widening margins. Soviet T-34 design philosophy deliberately sacrificed individual performance optimization to achieve maximum production efficiency. The Christie suspension system was less sophisticated than German torsion bars, but could be manufactured using standard automotive components. The transmission system utilized truck gearing that was less refined but could be produced by any heavy machinery factory. The turret incorporated basic optical sights that were adequate for most combat ranges while requiring minimal specialized manufacturing. Most significantly, T-34 design incorporated standardized components that could be manufactured using semi-skilled labor and standard industrial equipment.
Armor plate was simple rolled steel that could be produced by any steel mill. Engine components were based on proven diesel designs that could be manufactured by tractor factories with minimal modification. Assembly procedures were simplified to minimize skilled labor requirements and reduce production time. Quality control standards were adjusted to prioritize functional effectiveness over precision manufacturing. T-34 tanks were considered acceptable if they could travel 100 kilometers, fire their main gun accurately at combat ranges, and provide adequate protection against standard anti-tank weapons. German quality control standards required precision manufacturing that ensured optimal performance under all conditions, but delayed production and increased unit cost. The mathematical result was predictable. Soviet factories were producing functional tanks faster than German factories could produce superior tanks. In sustained combat operations, functional adequacy multiplied by overwhelming numerical superiority was proving more effective than technical excellence constrained by limited production capacity. Inside German tank production facilities, the reality of industrial constraints was becoming visible to engineers and production supervisors who had previously focused exclusively on technical excellence rather than manufacturing efficiency. The Henschel plant in Kassel, producing Tiger I tanks, exemplified the challenges facing German armor production. Master craftsman Heinrich Bauer had supervised Tiger tank assembly for 8 months and understood every technical detail of the manufacturing process. Each Tiger required 300,000 individual parts manufactured to precision tolerances that demanded specialized tooling and skilled assembly techniques. The transmission alone incorporated 1,200 precision-machined components that required individual fitting and adjustment by experienced technicians. The turret design incorporated advanced optical range-finding equipment that enhanced gunnery accuracy but required precision machining and electronic components manufactured by specialized facilities. These technical sophistications provided measurable advantages in individual combat engagements. German tank crews achieved higher hit probabilities, better armor protection, superior mechanical reliability, and longer operational range than most Soviet tank crews. But technical superiority was being overwhelmed by numerical disadvantages that were increasing monthly as Soviet production exceeded German output by ever-widening margins. Soviet T-34 design philosophy deliberately sacrificed individual performance optimization to achieve maximum production efficiency. The Christie suspension system was less sophisticated than German torsion bars, but could be manufactured using standard automotive components. The transmission system utilized truck gearing that was less refined but could be produced by any heavy machinery factory. The turret incorporated basic optical sights that were adequate for most combat ranges while requiring minimal specialized manufacturing. Most significantly, T-34 design incorporated standardized components that could be manufactured using semi-skilled labor and standard industrial equipment. Armor plate was simple rolled steel that could be produced by any steel mill. Engine components were based on proven diesel designs that could be manufactured by tractor factories with minimal modification. Assembly procedures were simplified to minimize skilled labor requirements and reduce production time. Quality control standards were adjusted to prioritize functional effectiveness over precision manufacturing. T-34 tanks were considered acceptable if they could travel 100 kilometers, fire their main gun accurately at combat ranges, and provide adequate protection against standard anti-tank weapons. German quality control standards required precision manufacturing that ensured optimal performance under all conditions, but delayed production and increased unit cost. The mathematical result was predictable. Soviet factories were producing functional tanks faster than German factories could produce superior tanks. In sustained combat operations, functional adequacy multiplied by overwhelming numerical superiority was proving more effective than technical excellence constrained by limited production capacity. Inside German tank production facilities, the reality of industrial constraints was becoming visible to engineers and production supervisors who had previously focused exclusively on technical excellence rather than manufacturing efficiency. The Henschel plant in Kassel, producing Tiger I tanks, exemplified the challenges facing German armor production. Master craftsman Heinrich Bauer had supervised Tiger tank assembly for 8 months and understood every technical detail of the manufacturing process. Each Tiger required 300,000 individual parts manufactured to precision tolerances that demanded specialized tooling and skilled assembly techniques. The transmission alone incorporated 1,200 precision-machined components that required individual fitting and adjustment by experienced technicians. The turret design incorporated advanced optical range-finding equipment that enhanced gunnery accuracy but required precision machining and electronic components manufactured by specialized facilities. These technical sophistications provided measurable advantages in individual combat engagements. German tank crews achieved higher hit probabilities, better armor protection, superior mechanical reliability, and longer operational range than most Soviet tank crews. But technical superiority was being overwhelmed by numerical disadvantages that were increasing monthly as Soviet production exceeded German output by ever-widening margins. Soviet T-34 design philosophy deliberately sacrificed individual performance optimization to achieve maximum production efficiency. The Christie suspension system was less sophisticated than German torsion bar.
Strategic materials analysis revealed additional constraints that made German production expansion impossible, regardless of manufacturing organization or labor allocation decisions. Tank production required specialized steel alloys, precision machinery, skilled labor, and industrial facilities that were being depleted faster than they could be replaced or expanded. Chromium requirements for armor steel exceeded German imports by significant margins. Each Panzer IV required approximately 850 kilograms of chromium nickel steel for armor protection. Monthly Panzer IV production of 267 units consumed 227 tons of chromium, while total German chromium imports averaged 180 tons monthly. The deficit was covered by depleting strategic reserves that would be exhausted within 6 months at current consumption rates. Molybdenum supplies for advanced steel production were even more constrained. Tiger tank armor incorporated molybdenum alloys that provided superior hardness characteristics, but required strategic materials available only from limited sources. German molybdenum stocks were sufficient for approximately 400 Tiger tanks, after which production would need to utilize inferior steel alloys that reduced armor effectiveness. Machine tool requirements for precision manufacturing exceeded German production capacity and import availability. Each new tank production facility required specialized equipment, including precision lathes, hydraulic presses, heat treatment furnaces, and quality control instrumentation. Expanding production capacity required machine tools that were needed for aircraft production, ammunition manufacturing, and naval construction programs. Skilled labor shortages were becoming critical as experienced machinists, welders, and assembly technicians were conscripted for military service. Training replacement workers required months of instruction and apprenticeship that delayed production while consuming the time of experienced supervisors who could otherwise focus on manufacturing operations. Soviet resource mathematics appeared more favorable due to geographic advantages and industrial organization that prioritized tank production over other military equipment categories. Soviet steel production in the Urals exceeded German output and was protected by strategic bombing by distance and air defense systems. Raw materials were available from territories beyond German military reach, including ore deposits in Central Asia and Siberia. Most significantly, Soviet industrial planning had allocated resources to maximize tank production capacity while accepting reduced availability of other equipment types. German industrial allocation attempted to maintain balanced production across multiple categories, including tanks, aircraft, submarines, and artillery, resulting in resource competition that limited maximum output in any single category. The conference that would fundamentally alter German strategic planning occurred on March 28, 1943, in the secure briefing room at Wehrmacht High Command Headquarters in Berlin. Present were the senior officials responsible for German armament production and strategic planning: Albert Speer, Minister of Armaments and War Production; General Friedrich Fromm, Commander of the Replacement Army; and Colonel General Heinz Guderian, Inspector General of Armored Troops. The meeting had been called to address declining German tank strength on the Eastern Front and develop solutions for maintaining armored force effectiveness against increasing Soviet numerical superiority. But the statistical analysis presented during the conference revealed that existing problems were symptoms of fundamental industrial inadequacies that could not be solved through organizational adjustments or resource reallocation. Albert Speer presented production statistics that quantified the scope of the crisis facing German armored forces. Total German tank production since the beginning of 1943 had delivered 1,247 new vehicles to operational units. Intelligence estimates indicated that Soviet production during the same period had exceeded 6,000 tanks delivered to frontline formations. The production ratio favoring the Soviet Union was approaching 5-to-1 and continuing to worsen. Wurm's analysis of replacement requirements confirmed that current German production capacity was insufficient to maintain existing force levels. Armored divisions on the Eastern Front required approximately 2,000 replacement tanks annually to compensate for combat losses, mechanical failures, and normal attrition. German production capacity totaled approximately 1,800 tanks annually across all types, creating a deficit that would deplete German armored strength regardless of tactical success. Colonel General Guderian's presentation revealed the combat implications of production disparities. German armored divisions were being reduced to regimental strength through irreplaceable equipment losses. Soviet armored formations were being reinforced to strength levels exceeding their original authorization. Individual German tactical superiority was being overwhelmed by numerical disadvantages that were increasing monthly. The most sobering aspect of the analysis was recognition that production disparities were accelerating rather than stabilizing. Soviet industrial capacity was expanding, while German capacity remained constrained by strategic bombing, resource depletion, and labor shortages. Every month of continued fighting would worsen the strategic balance until German defeat became not just probable, but mathematically certain. Strategic alternatives were limited and unattractive. Expanding German tank production would require resources diverted from aircraft and submarine programs that were essential for defense against Allied bombing and naval interdiction. Reducing quality standards to increase production speed would eliminate technical advantages that partially compensated for numerical inferiority. Limiting offensive operations to conserve equipment would surrender initiative to Soviet forces equipped with unlimited replacement capacity. The conference concluded with acknowledgement that Germany lacked the industrial capacity to sustain prolonged armored warfare against the Soviet Union. Future strategy would need to emphasize defensive operations, anti-tank weapons, and infantry tactics that minimize dependence on tanks while maximizing casualties inflicted on numerically superior enemy forces. As the participants filed out of the conference room, each carrying classified reports that would reshape German military strategy for the remainder of the war, none fully comprehended that they had just witnessed the mathematical proof of inevitable German defeat on the Eastern Front. The production statistics revealed a truth more devastating than any battlefield loss. Germany was fighting an industrial war with peacetime production methods against an enemy who had transformed their entire economy into weapons manufacturing system. The 6,000 German tanks represented engineering excellence, but the 84,070 Soviet tanks represented mathematical inevitability. But the full implications of the production war extended beyond simple numerical comparisons. Soviet industrial capacity was not just superior, it was accelerating, while German capacity declined under strategic bombing, resource depletion, and labor shortages. Every month of continued fighting would worsen the strategic balance until German defeat became not just probable, but mathematically certain.
Alternative material sources were limited and politically complicated. Chromium imports from Turkey required diplomatic concessions that competed with other strategic priorities. Molybdenum mining in occupied territories required resources and security commitments that were needed for other military operations. Domestic material recycling could not provide sufficient quantities to sustain production at even current reduced levels. Soviet resource availability appeared unlimited by comparison. Intelligence reports indicated that Soviet steel production in the Urals exceeded German output by significant margins and was continuing to expand through new facility construction and existing capacity improvement. Raw material sources included ore deposits in territories beyond German military reach, providing strategic depth that guaranteed continued production regardless of battlefield outcomes. The strategic material analysis revealed that German industrial planning had been based on assumptions about campaign duration and resource requirements that proved fundamentally incorrect. The German economy had been organized for short-term maximum production rather than sustained industrial warfare. Soviet economic organization prioritized long-term production capacity over short-term efficiency, creating cumulative advantages that were becoming decisive. Professor Ferdinand Friedensberg, directing the Reich Office for Economic Development, submitted reports that recommended immediate transition to defensive strategy focused on resource conservation rather than continued offensive operations that depleted irreplaceable strategic materials. His analysis concluded that Germany lacked the industrial capacity to sustain armored warfare against enemies equipped with unlimited replacement capability. Allied strategic bombing of German industrial facilities was accelerating the decline of tank production capacity, while Soviet production facilities remained protected by distance and air defense systems that prevented effective interdiction. The bombing campaign revealed additional vulnerabilities in German industrial organization that had not been anticipated during strategic planning. Air Marshal Arthur Harris's bombing directive prioritized German industrial targets that included tank manufacturing facilities, component suppliers, and transportation networks essential for production coordination. The Krupp works in Essen had suffered significant damage during multiple raids that destroyed precision machinery, disrupted production schedules, and forced resource allocation to facility repair rather than expansion. Production disruption extended beyond direct physical damage to include psychological effects on workforce productivity and supply chain interruption that created delays throughout the manufacturing process. Workers required shelter time during air raids that reduced productive hours. Transportation delays caused component delivery problems that interrupted assembly line operations. Soviet production facilities were effectively immune to strategic bombing due to geographic location beyond the range of German bomber aircraft. The relocation of industrial capacity to the Urals during 1941 had created strategic depth that protected Soviet tank production from direct attack, while allowing continuous expansion of manufacturing capacity. The mathematical implications were devastating for German strategic planning. Allied bombing was reducing German tank production capacity, while Soviet production capacity continued expanding without interference. The industrial balance was shifting more rapidly than battlefield outcomes could compensate, creating irreversible trends toward German numerical inferiority. Armament Minister Speer calculated that strategic bombing was reducing German tank production by approximately 25% compared with optimal capacity, while intelligence indicated that Soviet production was increasing by 15 to 20% quarterly through facility expansion and process improvement. The combined effect was production ratio changes that would make German armored force maintenance impossible by late 1943. Direct comparison between German and Soviet production methodologies revealed fundamental differences in industrial philosophy that explained how the Soviet Union was achieving superior output despite starting the war with apparent technological and organizational disadvantages. The production revolution occurring in Soviet factories represented systematic application of mass production principles to military equipment manufacturing.
Soviet assembly line organization divided tank construction into standardized operations that could be performed by workers with minimal technical training. Component standardization allowed interchangeability that simplified assembly procedures and reduced quality control requirements. Production processes were designed for continuous operation with minimal maintenance shutdowns or adjustment periods. German production methods emphasized precision manufacturing that required skilled craftsmen to perform complex assembly operations that could not be simplified without compromising technical performance. Component tolerances demanded individual fitting and adjustment that prevented rapid assembly line techniques. Quality control standards required extensive testing and verification that reduced production speed. The productivity comparison was striking. Soviet workers were completing T-34 tanks at rates of 1.2 vehicles per worker annually, while German workers were completing Panzer IV tanks at rates of 0.7 vehicles per worker annually. Soviet productivity advantages reflected industrial organization optimized for maximum output rather than optimal individual unit performance. Factory efficiency expert Heinrich Nordhoff studied Soviet production techniques through intelligence reports and concluded that German manufacturing philosophy was fundamentally incompatible with total war requirements. His analysis recommended immediate adoption of Soviet mass production methods, but implementation would require complete reorganization of existing facilities and abandonment of quality standards that provided German technical advantages. The strategic choice was becoming clear. Germany could maintain technical superiority with limited production quantities, or adopt mass production methods that would increase output while reducing individual unit effectiveness. Either choice would result in numerical inferiority against Soviet forces equipped with adequate tanks produced in unlimited quantities. May 15, 1943. Reich Chancellery, Berlin. Secure conference room. The meeting that would determine Germany's industrial strategy for the remainder of the war brought together the senior officials responsible for tank production and strategic planning. Present were Albert Speer, Colonel General Guderian, General Fromm, Dr. Kerr, and Professor Krupp, along with statistical analysts who had compiled comprehensive assessments of production capabilities and resource requirements. The conference agenda focused on developing solutions for maintaining German armored force effectiveness against increasing Soviet numerical superiority. But the statistical evidence presented during the meeting demonstrated that existing problems reflected fundamental industrial inadequacies that could not be solved through organizational adjustments or resource allocation. Speer opened the discussion by presenting updated production statistics that quantified the accelerating crisis facing German armored forces. Soviet tank production was estimated at 2,000 to 2,500 units monthly and continuing to increase, while German production remained constrained at approximately 500 units monthly across all types. The production ratio was approaching 5-to-1 and would worsen as Soviet capacity expanded while German capacity declined due to strategic bombing and resource depletion. Dr. Kurl's resource analysis confirmed that strategic material constraints would force production reductions beginning in summer 1943, regardless of organizational efficiency improvements. Alternative materials and recycling programs could not provide sufficient quantities to maintain current production levels. Import possibilities were limited by transportation difficulties and diplomatic complications that competed with other strategic priorities. General Fromm presented operational assessments demonstrating that German armored divisions were being depleted faster than replacement capacity could restore combat effectiveness. Current replacement rates would maintain existing force levels only if combat losses were reduced by 60%, a requirement that was incompatible with continued offensive operations or effective defensive responses to Soviet attacks. Colonel General Guderian's tactical analysis revealed that individual German tank superiority was being overwhelmed by Soviet numerical advantages that were increasing monthly. German tank crews were achieving impressive kill ratios but were being overwhelmed through attrition that favored unlimited Soviet replacement capacity over superior German individual unit performance. Professor Krupp presented industrial analyses that demonstrated the impossibility of matching Soviet production rates using German precision manufacturing methods. Converting to mass production techniques would require complete facility reorganization, workforce retraining, and quality standard modifications that would eliminate technical advantages while failing to achieve quantitative parity with Soviet output. The conference participants recognized that Germany faced an unsolvable industrial equation. Maintaining quality standards prevented achievement of necessary production quantities. Adopting quantity production methods would eliminate quality advantages without achieving numerical parity. Resource constraints prevented expansion regardless of organizational decisions. The final assessment revealed mathematical certainties that challenged fundamental assumptions about German military capabilities and strategic planning. Statistical analysis demonstrated that continued armored warfare against the Soviet Union would result in complete German tank force depletion regardless of tactical success or individual unit performance superiority. Current German armored strength totaled approximately 2,400 operational tanks across all fronts, with monthly replacement capacity of 500 units. Monthly combat losses averaged 600 to 800 units, creating deficits that were depleting total force strength by 100 to 300 tanks monthly. Mathematical projection indicated complete armored force elimination within 12 to 18 months if current loss rates continued. Soviet armored strength was estimated at 8,000 to 10,000 operational tanks, with monthly production exceeding 2,000 units. Combat losses averaged 1,200 to 1,500 monthly, but replacement capacity exceeded losses by significant margins that allowed continuous force expansion. Mathematical projection indicated Soviet armored strength would exceed 15,000 tanks by spring 1944. The production comparison revealed the scope of German industrial defeat. German total tank production since 1939 had delivered approximately 25,000 vehicles to operational units. Soviet production during the same period was estimated at 45,000 tanks, with production rates accelerating while German rates declined due to resource constraints and strategic bombing. Strategic material analysis confirmed that German production decline was irreversible under existing resource constraints. Alternative materials and efficiency improvements could not compensate for fundamental shortages in chromium, molybdenum, and tungsten required for advanced armor and ammunition production. Soviet resource availability appeared unlimited due to geographic advantages and industrial organization that prioritized tank production over other equipment categories. The mathematical conclusion was undeniable. Germany had lost the industrial war that would determine the outcome of armored operations on the Eastern Front. Individual technical superiority could not compensate for numerical inferiority that was increasing exponentially as Soviet production exceeded German capacity by ever-widening margins. In the depths of German and Soviet factories, the mathematical equations that determined the outcome of the largest armored conflict in military history had been calculated by industrial workers rather than military strategists. The 6,000 German Panzers represented precision engineering excellence, but the 84,070 Soviet tanks represented the industrial mathematics of total war. German engineers had approached tank design as an opportunity to incorporate advanced technology and superior performance characteristics, creating vehicles that were individually superior but could not be produced in quantities necessary for strategic success. Soviet engineers had approached tank design as a mass production problem, creating adequate vehicles that could be manufactured in quantities that overwhelmed enemy forces regardless of individual performance comparisons. The strategic lesson was mathematical rather than tactical. Modern wars were won by factories rather than battlefields. Industrial capacity to sustain force levels during extended conflicts was more important than individual weapon system superiority. Nations that could produce adequate equipment in overwhelming quantities would defeat nations that produced excellent equipment in limited quantities. Admiral Yamamoto's prediction about American industrial capacity had proven equally applicable to the Eastern Front. Germany had awakened a sleeping giant whose industrial capacity would ultimately overwhelm German military effectiveness through mathematical inevitability rather than tactical superiority. The tank production war had ended before the battlefield war concluded. decided by engineers and factory workers whose production decisions determined strategic outcomes more than the tactical brilliance of tank crews who fought with whatever equipment their nations could provide. In total war, industrial mathematics proved more decisive than military excellence, and the Soviet Union had won the industrial war that mattered most.